On February 18th, NASA's Perseverance rover will finally touch down on the red planet's surface, making some serious waves that will help scientists better understand Mars's interior structure. Believe it or not, this landing is going to make history, as it's suggested that one other lander on the surface of Mars will be able to pick up the seismic waves generated by the landing. We're going to dive into what this might mean, and how this might revolutionize our view of Mars. But first, be sure to hit that like button, comment your favorite geological feature on Mars, smash that subscribe button, and ring that bell to never miss a video. I'm Eric Malachite, author of Echoes of Olympus Mons, and this is ScienceGet. So Perseverance will be entering Mars's tenuous atmosphere on February 18th, and during its initial entry, the capsule containing the rover will deploy a parachute before jettisoning the bottom covering and dropping the lander onto the surface. The landing module of Perseverance is actually two different pieces. The top portion is an apparatus featuring landing thrusters that will help Perseverance land as safely as possible, slowing the craft's descent considerably. The final stage of the landing sees the top apparatus separating from the lander, suspending it on cables as Perseverance careens toward a 45-kilometer wide crater known as Jezero. Yet, even though this is going to be a fairly soft landing, Perseverance's cousin lander InSight has built-in seismic detectors which will be able to pick up the vibrations caused by the lander's descent. InSight, with the help of its super-sensitive seismometer suite, has already picked up hundreds of Marsquakes since it landed in the Elysium Planitia in November of 2018. Did I say that right? Oh well. Moving on. This data has helped scientists back here on Earth to construct a detailed map of the red planet's interior structure in unprecedented detail. The InSight team member and study lead Ben Fernando, a PhD student at the University of Oxford in England, says this is tricky work on Mars, stating, "Unlike on Earth, where you can independently figure out when and where a seismic source happened, and of course how big it was, on Mars we've got a single station, and we're both trying to identify the mechanics of the source and the structure of the planet that the waves propagated through." Disentangling those two from each other is not necessarily trivial. In the simplest explanation, if you were in a room and you couldn't see, it's hard to tell if someone's speaking loudly far away or quietly close to you. And in addition to that, if you didn't know what the shape of the room was, it'd be even harder. When Perseverance lands on Mars, it will make history, in that we've never attempted to detect seismic waves from an object hitting the surface of another world before. But will this impact, get it?
Yeah, nailed it.
What NASA already knows about the red planet's interior? Well, first, we'll have to discuss how seismic monitors on Earth are used to understand what's happening beneath our feet, and how this approach might differ on Mars. On Earth, we have a variety of different methods that help to inform scientists on the interior structure of the Earth. For example, on January 17th of 1997, a magnitude 6.9 earthquake near Northridge, California, literally rocked the majority of the Earth's surface, releasing comparable force to 2 billion kilograms of high explosives being released at once. This event killed 51 people and caused over $20 billion in damage. It also raised the Santa Susana Mountains north of Los Angeles by 70 centimeters. But it also created seismic waves that ricocheted throughout the Earth's core, and these waves were recorded by geophysical observatories around the world. So despite the tragic loss of life, some good has come of that data, because understanding the Earth's interior structure and mechanics can lead to better preparedness for future earthquakes. Maybe even the big one that's been expected from the San Andreas Fault for decades now. You know, the one they based Escape from LA on? What? What do you mean none of you kids have seen Escape from LA? Next you're going to be telling me you haven't seen Big Trouble in Little China or John Carpenter's The Thing. Oh wait, am I old? Because seismic waves travel through the materials that make up the Earth's interior at different rates, geophysicists are able to identify what materials make up the interior of the Earth. For example, S-waves are not detected in the outer core of the Earth, since liquids like molten metal and magma can't be sheared, but we do detect them in the inner core, which means that the inner core of the Earth is solid. The waves we detect in liquids are called P waves, or PKP waves, and these are the waves we detect in liquid magma and the outer core. There are numerous geophysical stations around the world which are used to map the interior of the Earth in precise detail. It's how we know that there's a giant magma plume beneath Yellowstone National Park, for example. Okay, so how is this useful to us when trying to figure out how this type of data will be used on Mars? Well, let's get into some speculation. Seriously? Do I have to say hypothetical or something? I guess so. Perseverance will be using the same landing protocols and strategy that got Curiosity to the surface safely, so the team knows precisely how much force will be generated from the impact. But as the study lead behind InSight suggested, it will still be challenging for them to interpret the seismic data generated by the landing because, unlike here on Earth, where we have seismic monitoring stations around the world, there's only one on Mars that will be capable of detecting these waves. It's been said that the only thing we're really certain of about Mars's interior is that it has a core with a radius of about 1,500 to 2,000 kilometers. We know this thanks to the measurements of the planet's moment of inertia taken by Mars Pathfinder. Moment of inertia is the way in which a planet rotates on its axis. This rotation causes disturbances of the material within the planet, and instruments can pick this activity up and interpret them much in the same way that seismic waves are used to map the interior of the Earth. But the portion of Mars's interior stretching from the surface of the crust to the core is a complete mystery to us, and one we'll have to have a better understanding of before we go sending people there. However, there are some clues on the surface of the planet that can inform us on what the interior of the planet might be like. For instance, because Mars is smaller than the Earth but around the same age, we know that its crust is much thicker than ours. Because of its size and age, the upper portions of the planet have cooled to a larger extent than the Earth's. And I'm sure the damage to the core left over from whatever cataclysmic event stopped its core from generating a magnetosphere didn't help this process. The crust in the north of the planet is far thicker than the crust in the south, most likely because of the event I just mentioned. And the presence of volcanoes on Mars's surface also suggests that there is some kind of convection going on inside the planet, though we're really not certain what the source would be. On that note, there's been some speculation. Be careful what you wish for, right? If there's any volcanic activity on the planet at all. For years, I've heard scientists go back and forth on whether or not Olympus Mons, the biggest and most badass volcano in the solar system, is dormant, dead, or possibly active. Some relatively new research has drawn into question just how dead Mars is, though, suggesting that the planet's geological activity may simply be dormant for now. In our video on the strange volcanoes we've observed on Venus's surface, we talked about volcanic activity and volcano structures that are absolutely alien to anything found on Earth. We like to think that geological activity will behave similarly no matter what planet we find it on, but this might not be the case. This new data suggests that in the Tharsis region of Mars, where Arsia Mons, Pavonis Mons, and Ascraeus Mons are all located, may be geologically active after all, and that the eruptions may cause magma to plume and move beneath the surface rather than above it. While there has been no volcanic activity detected in the time since we've been observing Mars, evidence does suggest that volcanic activity may have happened on the Red Planet much more recently than we originally thought. This brings us back to what InSight might detect from Perseverance's landing. If the seismic waves we detect are P waves, then it will suggest that there could be liquid magma churning beneath the surface of the Red Planet. It's just unfortunate that the Tharsis region is pretty far away from the Jezero crater where Perseverance will be landing. Still, it will be huge news if P waves are detected beneath this region, as it will either mean liquid water or magma beneath the surface. Whatever the case is, you can bet that we'll be watching for the data to be revealed on February 18th and beyond. Until then, we'll just have to wait and see what happens. If you dug this video, be sure to drop a like and comment your favorite thing about seismology. And be sure to smash that subscribe button and ring that bell to never miss an episode of Science Get. I'm Eric Malachite, and I'll see you next time.